In this video, we'll be looking at the measures of spread of continuous distributions. So the spread refers to the variance and the standard deviation. Now we know how to calculate these for discrete distributions. We've previously calculated them before. However, now we're going to look at the continuous distributions and referring them to the fx, sort of the graphs that represent the continuous distribution. So once you know, like standard deviation is just a square root of variance. So you should remember that. So standard deviation is equal to the square root of variance. So once you know variance, it's relatively easy to calculate. So we'll begin by showing how to calculate the variance. Now there are two ways to calculate it. However, we'll look at the first one, and for both you can use both formulas. However, just decide which one you'd prefer. You could memorize both of them if you'd like, but both of them do work. So the first is that they involve anti-diffing. So you go infinity to negative infinity. Then x minus the mean squared times fx dx. And this will give you the variance. Then you can interchange that if you change that, which this is equivalent to a and b if x is defined between the domains of a and b. So if you remember before with the fx, they can be infinity to negative infinity, or generally more likely they're going to be defined between two domains. Then you have a and b there, x minus mean squared, and then it's just the same formula, but you've changed a and b. Dx, and that equals the variance. And just to point out that here, that symbol there refers to the mean. And if you look in the previous video, the measures of central tendency, we've already looked at how to calculate the mean. So you should be able to calculate the mean of the continuous distribution, sub that value in, x minus that, square it, times it by whatever the fx is, anti-diff it, and you can find the variance. The second way you can calculate the variance comes from the formula that the variance is equal to e x squared minus e x squared. And you should remember this formula from the previous times we've calculated variance, as it applies to other distributions as well. So it's a general formula. And that's why this way is often preferred, because you can refer it back to this formula which you've used previously. Now we know that e to the x, that's the mean, is equal to either infinity or a negative infinity or a, b. So I'll just assume a, b. Remember, you can swap the infinity and negative infinity. X times fx dx. And that gives us the formula for the mean. Now this is saying x squared, so therefore you can say that the variance of x is equal to a b x squared times fx dx minus then ex, so whatever that is there, squared. Think about this as a b x squared dot fx dx minus the mean squared. And that's another way you can calculate the variance. Now in both cases, so in both, you need to calculate the mean. Because if you remember in the previous formula we used the mean, and in this formula here you can obviously see the mean is used again. So be looking questions, if they say calculate the mean and then just calculate the variance, like note what answer you got for the mean, because then you'll then need to use it. So there's that formula for the variance, and then if we remember before, the other alternative way to calculate it was ab x minus the mean squared times fx dx. And here's just the integral, so you have to anti-diff, sub in whatever the fx formula is into the equation, and the mean is there. So you can see the slight similarities, and both are fine and will work for whichever question you want to do. So moving on to a question, it says find the standard deviation of fx is equal to this distribution here. You can see that. So the first thing to note is they ask to find the standard deviation. However, to find the standard deviation, we must first find the variance. So first find variance. And to first find the variance, we must calculate the mean, because with both formulas you have to calculate the mean. So I'm going to use the formula that the variance is equal to e x squared minus e to the x squared. So the first thing to do is we'll find e to the x. Find e to the x. So e to the x is equal to 3, 2. And you can see there, that's 3 and 2, that's the domain. X minus 3 on 2 dx. And then, oops, sorry, I forgot, then you have to times that all by x dx. And so just a quick note, because I forgot the x there initially, if you don't forget to put it in and you calculate this, it will equal 1. So when you have the expected values equal to 1, just make sure that you have not forgotten the x. So if e to the x is equal to 1, then check for the extra x. And the reason why it will equal 1 is because if you don't leave the x in, you're just finding the integral, the area of the entire distribution, continuous distribution, which obviously is just going to be 1 because the total area equals the total probability, which equals 1. So we solve for this and we'll find that 3 and 2 x squared minus 3 on 2x dx is equal to integrated x on 3 minus x squared 3 on 4, because you bring the 2 down, you get 2 on 4, which is 1 on 2. Integrate, and then 3, 2. Then we can sub those values in, and we get 27 on 3 minus 3, 27 again, because 3 squared is 9 times 3, 27 on 4, minus that by 8 on 3, minus 4 times 3 is negative 12, so 12 on 4. Equal to 31 on 12. So we found EX. Okay. So then that we know that EX is equal to 31 on 12, variance is equal to this. So now we need to calculate this part of the equation. So we'll say that E to the x squared. Now this is equal to 3 on 2 x squared times x minus 3 on 2 dx. So the x squared is is x squared. That's coming from the x squared plus e to the x, and then you put in the formula. So here is equal to fx, and that is always equal to x squared. So it's x squared times fx. You can solve that, and you get the integral of, we'll expand it out first, 3 on 2 x cubed minus 3 on 2 x squared dx. And the integral of that is equal to x to the 4 over 4 minus x to the 3 on 6, which can be simplified to 1 on 2. Integral of that is 3 on 2. We'll go back up to here. Then we find that 3, we can sub it into the calculator, it's probably easiest, but you can still go by hand, sort of 3 to the 4, so 3, 9, 27, 81, sub those in. However, just for simplicity, we'll put into the calculator. We find that e to the x squared is equal to 27 on 4. Now we know that e to the x is there, so we just need to, now we can work out what the variance is. So we go, the variance is equal to 27 on 4 minus 31 on 12 squared. Don't forget to square it. The squared, because e to the x is just that, but we do need to square it. And then we can get that is equal to 27 on 4 minus 961 on 144, which is equal to 11 on 144. So quite a big number. If they were to do it by hand, then you wouldn't get such a big number. However, yeah, the numbers would work out a bit easier to cancel, but if you do have to do it by Tech Active, like the calculator, and it doesn't say decimal places, then you have to leave it as an exact value. But of course, the question didn't ask for the variance, the question asked for the standard deviation. So now we know that the variance, we can just square root that, and we can easily find the standard deviation. So we can say that the standard deviation is equal to the square root of the variance. Now we know that the variance was equal to 11 on 144. Then we can go the square root of 11 on 144 is equal to the square root of 11, and square root of 144 is 12. So we know that the standard deviation is equal to square root of 11 on 12. So this is an exact answer. So that's if they didn't ask for any decimal places. If they did, then you put into your calculator and you put it down to however many decimal places the question asked for.